Hello, our most valued student. My name is Confident. Welcome to our session today in mathematics, where I focus on some math errors which are hurting your good pass. So I've been time and again working with some students, and you always pick up a trend, especially when it comes to the errors that are made in mathematics, and you see something common that students usually commit. And in this section, I just want to kind of look at some of these errors which, if you can avoid, your maths can automatically skyrocket. So it says, do you know it is mainly a few errors that are costing you big time in your mathematics? Once acknowledged and fixed, your maths, let's say your maths will automatically skyrocket. Sometimes, as I said, when I work with students, you might find that they make just a small error and they dismiss it as it was just a small error. Should I have done it or avoided this error, I would have gotten the answer right. But the problem is, these errors are always repeated even in your final exams, and they are costing you your good pass in that final exam. For example, when you are working with let's say you are revising or doing your revision, and you made an error maybe with a negative sign, and it actually changed the whole answer. I say to you students, you must make an issue out of it. I usually make an issue with my students when they make such errors. You need to kind of punish your mind, punish yourself to say, you cannot make this error, in as much as it is a minor error. You know why? It is the reason behind the failure in your mathematics. So even if it's a small error, don't just dismiss it as, I know that it was a small error. Make an issue out of those errors. Just tell yourself, just pace up, stand up, pace up, just pinch yourself a little bit and just tell yourself, I cannot continue making these errors. You know why? When you make an issue out of it, your mind, your subconscious will record it, and next time in a pressure situation like an exam, your mind will pick it up to say, be careful, they're trying to expose if ever you have fixed those errors. Remember, the exam is about exposing your errors. It's about making the error which they are expecting you to make. They know that when they put you in a corner, you're going to fall for the trap. So you need then to be careful of some of these errors. Let me go through a few of these, and I will time and again bring different scenarios where they usually catch you guys. Now let us look at this. This is a quadratic equation, and students are supposed to solve here for x. And again, it's not a problem for them to identify. There is a 1 there, so you'll be able to identify that my a is 1, my b is -5, and my c is -24. Then it comes in the substitution into the formula here. You remember, this is, as I said, it's the quadratic formula, and when you're writing, you're saying x is equal to minus b. You see that b is -5, so it's minus bracket -5, which is good, and then plus or minus square root of -5 squared, which is b squared, -4. My a is 1 and my c is -24. This should have extended like that. Let me just give it a little bit of space like that. All right, and then it's all over, and then it's 2 and my a is a 1. So this is the scenario you have substituted, but I don't know if ever you picked up the error that I've already made. Did you pick up the error, or can you see the mistake that I made in substitution here? If you do it well, you will see that I was supposed to put a negative, a bracket in that negative. Failure to do that, it makes the whole solution wrong. I repeat again, let me remove that. If you say -5 squared with a calculator, you will see that it will give me -5 squared gives me a -25. But if I say -5 squared in brackets, it gives me instead a +25. So that -25 and +25 changes everything. So here, there is the error. What are you supposed to do? You are supposed to, every time when you substitute, ensure that there are brackets, especially here, that is where students are making an error. So that is that. Sometimes there is a slight error that students also make. If I can come back to say here, it's not much a big issue, but this is what they do. They divide, or they put their division line just up to that point, like this. So this is what they do when they are writing the formula. The formula, you look at the formula, it's clear that the division line is extending up to B, but you find students now their division line is extending up to that what do you call it, the root sign. So they forget that the division line is also supposed to affect that side of the math. So just be careful on that one. And then the next one is similar again. The question will be solved for x, and you find students solving, simplifying a lot of what I can call it a long mathematical algebraic problem, and then they come to this scenario. And then after doing all the heavy lifting of that mathematics and simplifying and doing all the stuff, they face this situation and they are stuck. They don't know what to do. Now here, whenever they say solve for x, as I say, it might be simpler to you just looking at it now because I just brought it like that. But in a pressure situation whereby you are solving other stuff that led to this kind of a problem, you find students getting stuck to say, what do I do? Now, things that you are not supposed to do. Number one, if they say x squared, then you take 5x to the other side, you'll have 5x like that. And then from there, you can see that you can divide by x, and then remember x squared, when you divide by x, only one will remain. So you're left with saying x is equal to 5. This answer will be correct, but the method here is wrong, because when you say x squared, you must get how many answers? You have to come up with 2 answers. So you'd have lost an answer there. So that is one of the major problems. The second problem that students do is they just got stuck to say, I've got 2 items and I don't know what to do. Now my advice is, when you are in this scenario, always go to your what I call it, your escape door. Your escape door here is your quadratic equation. Always write your quadratic equation. X is minus b plus or minus square root of b squared minus 4ac divided by 2a. Why the quadratic equation? Every time the highest power is 2, it means it can be solved by the quadratic equation. There are simpler ways to do it, as I'm going to show it here. This the most common way to do that, but because you're in an exam and you're pressured up, just go through the quadratic equation. What am I saying? In this quadratic equation here, there is a 1, so your a is 1, your b is -5, and because you don't have a c, you put a 0 for that. So you're going to have x is equal to minus b is minus 5 plus or minus square root of, remember that error to say, you say minus 5 squared minus 4. Now my a is 1 and my c is 0. Then you divide that by 2 and 2 into 1. So this is how you need to remember, though the whole challenge was for you to see that the c is equal to 0. But now that is the most, I will say, always go to your escape door, and the quadratic formula whenever you're solving is always your way. Your mind must pick up to say, whenever I see an x squared and it's an equation, I must always, if I'm stuck, go through the quadratic formula. And these questions are usually the beginning of the questions that you find, especially in your exams. So the quadratic formula, guys, let it be your kind of your escape way of simplifying such problems. But what is the easier way? From here, you are supposed to take out the x. See, x squared minus 5x, x is common. Now x into x squared is x, minus x into 5x is 5. So this was the simpler way of doing that. So you've got x is equal to 0, or x minus 5 is equal to 0. So here x is equal to, take that to the other side, it is equal to 5. So in the previous method where I said, yeah, there was an error in doing it, whereby the method was saying x squared, you take 5 to the other side, is equal to 5x, and you divide by x on both sides. So what you discover here is that we are left now with x is equal to 5. You have got only one root, but you are going to lose out on this x is equal to 0. When it's a squared, it means it's two answers, first one and the second one. But if you divide by the you don't divide by an unknown, you don't divide by a variable, because you're going to lose that variable. So these are simple things, guys, I'm bringing. Similarly, when you get a question like this, solve for x again, don't always be tempted. Okay, let me just show you what's common with students when they solve this. So this is what they'll say, it's easier, x squared, they take 18 to the other side, then they'll say x squared is equal to 18, then they square root both sides, x squared is equal to square root of 18, and then they've got x is equal to, and then they get that square root of 18. You can use a calculator to get that. So this will be their answer, but this answer is not complete. It is correct, but it is half correct, so you get 1 mark for that. But look at this. If you are using a quadratic formula, you're going to say x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So it's a matter of identifying here your a is equal to 1, and then I don't have a b which is equal to 0, and then this is my c which is equal to negative 18. So if I'm solving here, I'm going then to say x is equal to minus b, which is minus 0, plus or minus square root of b squared, which is 0 squared, minus 4, my a is 1, my c is negative 18, all over 2, and my a is 1. Someone is saying, but that is too long for you to do, and you don't have to actually use the quadratic equation every time. But trust me, it helps you a lot. Now minus 0, it becomes 0. You can actually use a calculator here. Remember, the calculator will give you the answer here. So just be naive, just you don't have to, in a way, you're not proving to anyone that you know your math, but you just want to ensure that everything is correct. Just act naive, knowing that your answers are going to be correct. Don't want to act like you're in charge. Don't want to act like you are in a performance of some sort. Here, it's your final exam. You don't have any time to pretend. You have to be ensuring that whatever you do, you get everything correct. So let's say you have this, okay, and then I put a bracket, there is negative 18. All right, so it's 0 squared minus 4ac all over, if I do that, and then it's 2 into 1. So this is what I have, equal to, you see, I'm getting 3 root 2, and then I go change here. Remember, you have to change from positive to negative. I'm getting minus 3 root 2, so I got 3 root 2, or x is equal to minus 3 root 2. So look at this, the difference. But if I come here also, remember we said x was equal to square root of 18. So let me just find what is the square root of 18 on the other side. It's 3 root 2. So here I was going to have x is equal to 3 root 2. The problem with this method here is that students always forget to say when they square root at this stage. I think you've picked up. Look, I've got 1 and 2 answers, but here you just got 1 answer. They forget to say plus or minus. That's the only biggest challenge that students face whenever they are in this stage. You need to remember that there are 2 answers. One is positive and the other one is negative. I hope you're going to remember that. With the quadratic formula, you are forced to go through the whole scenario, and you are going to be tempted, not tempted actually, you're going to be forced to get the positive and to get the negative. So these are kind of the errors, as I say. Another part of the common error, students are supposed to expand here. Says expand 3x minus 5, 3x minus 5. It looks simpler, but students sometimes they trip here. You find that they always get challenged in that. What do? They say, is the FOIL method 3x multiplies 3x simpler? That 3x multiplies that, and that multiplies that, and that multiplies that. So this is what they will do. I hope you're going to pick it up. 3x times 3x, it's 6x squared. 3x times this is minus 15x. Minus 5 times 3 is minus 15x. Minus 5 times minus 5 is plus 25. This is what they'll get as this simplified version, but I don't know if ever you picked up the error. It's a very, very common error, and if you picked it up, that's good. I hope you're not going to repeat it. There is the error. 3 times 3 is not 6, but it is 9. Your mind will record as if it's saying 3 times 2, or I don't know how the mind does it, but you say 3 times 3, the mind will actually give you a 6. So sometimes this is what it does. Students are given this 3x minus 5 squared. It will be like that. And then a student sometimes doesn't want to kind of write it in. Remember, this is that. 3x minus 5 squared is that. So you find students doing this. They'll say 3 squared, then they say 6x, and then say 5 squared, they say minus 6x squared, then 5 squared, they say minus 25. You find students simplifying also like that. They take this squared to say 3x squared, they get 6x squared. It's not 6x squared because 3 squared is 3 times 3, which is 9. So it's 9x squared, but at the same time they take that squared inside, they say 5 squared is minus 25. It is fine, but you forgot the center parts here to expand, which is this part. So when you do that, you're going to get everything wrong. They will say even the negative sign also makes everything wrong. So whenever you're given this 3x minus 5 squared, remember the first time is to open the two brackets and then you use the FOIL method. It's just very, very, very important, guys. Don't be tricked, don't be tempted. Similarly, it's this kind of a problem. They will give you 3 cos it will be 3 cos x, 3 cos x. Oh, let me do it like this. You find the equation like this: 3 cos x, and then here it is a squared. You're supposed to simplify. Now this is this 3 cos x squared. It means 3 cos x, 3 cos x. Okay, but if you're given like this, you find students are also tempted. They'll say 3 squared, it's 6 cos squared x. You see, so the error that they make, the error most common is they think this 2 is 3 times. It's like it's 3 times 2 to get a 6. This is not correct, because what you're having is 3 cos x as a squared means 3 squared cos squared x. You see that now? 3 squared, this is a square here, not 3 times 2, and 3 squared is 9 cos squared x. I hope you're not going to be caught up by that error. It's a common one. Even here, as I said, the original one is 3 times 3. Instead of writing 6, remember guys, it's not 6, but it's 3 times 3 is 9. Cos x times cos x is cos squared x. Just remember that. These are the common errors, as I say, that students always make. Sometimes it's a simultaneous equation, as I said. Students find them doing a long kind of solution, and when it comes to the simplest parts, they always find themselves actually making errors. For example, here it says solve for x and y, and you find that students will take the first one as they are taught. Remember the simultaneous equation. You can see that y is much simpler, so I'll take it to the other side. So I'll have 2x plus 1 is equal to y. So this is my y. In this case, I can say therefore y is equal to 2x plus 1. This becomes my equation, usually it's my equation 3. And then when they have done that, they come here into this equation to do the substitution, just have a look at this. So it will be x squared, which is fine, minus 3x minus 4 minus y. Remember, you have your y as this, so where there is y, they will put 2x plus 1. Don't forget, you need to put brackets. Sometimes they forget that. It will just be minus 2x plus 1 minus, and then y squared. Now where there is y squared, remember y is bracket 2x plus 1 squared. If you have done this, don't forget these brackets. Because of two items, 2x plus 1, you need to protect that with a bracket, because this negative sign is not only affecting the 2x, it is only also affecting the 1. So be very careful there. That is where students also are making errors. But the next error that comes is here. That is where another error is picked up. So what you'll discover, or what you find students doing, or what you'll find yourself doing in that exam, you continue as x squared minus 3x minus 4, then you open, that is minus 2x, that negative becomes minus 1, and then it's minus. Now again, another error there. That negative, you need to know what to do, because this particular negative is, there are two things to be aware of. There is a squared and there is a negative. Two things to deal with there. So okay, suppose the negative, you didn't have an issue with it, but this is where the issue comes. They'll say minus, then they'll say 2 squared, and then it will be 4x squared, and then 1 squared, it will be plus 1. So sometimes they forget that negative, but don't forget, you still need to protect that with a bracket, because this negative is affecting what is inside here, but it cannot automatically enter until this is number 1 and this is number 2. You see, so you start with the square and then followed by that. So the students just do it. I don't know if ever you are seeing the error in this part. Are you picking up the error? If you are picking up the error is this 2x plus 1 squared is not that, because 2x plus 1 squared is equal to 2x plus 1 and another 2x plus 1. Remember that it's that, and then when you're expanding, that is the FOIL method. 2x times 2x and 2x times 1, 1 times 2x and 1 times 1, such that you're saying 2x times 2x, it is 4x squared. 2x times 1 is plus 2x, 1 times 2x is plus 2x, and 1 times 1 is plus 1. So you see that you lost this middle parts here. So by doing this squared and here, let me go back. By doing this to say here, this particular squared, by you thinking it multiplies, it squares there and it squares there, it's a very, very common error. Another common error that students sometimes face is when they are given that 2x plus 1 squared, you find them writing like a difference of 2 squares. You find them saying 2x plus 1 and they're saying 2x minus 1. It can't be a 2x minus 1. And then after that, of course, they will do the whole thing of multiplying and multiplying and multiplying, right, like that. And now their final answer will then become 4x squared minus 1. It's wrong, because the answer is correct the way you multiply it, but it's wrong because 2x plus 1 means you have got twice 2x plus 1 and 2x plus 1. It means twice. That's what it means. Just like x squared, it means it's x times x. So don't get tempted, or don't get fooled by that. Look at the last one that I wanted to bring. As I said, I'll bring some of these guys. I wish I could even write a book about the errors that students make. They are always common small errors, but they are responsible for most of the failures in your mathematics. Just get hold of these errors. As I said, make an issue out of it. Just make an issue out of a small technical error, I tell you, your subconscious mind will always give you a warning next time you want to find yourself on automatic in repeating that error. Remember, errors like this, it's in your subconscious. Sometimes you're not picking them up, but when you stop there, pause, ask yourself, why are you doing what you're doing? And then after that, kind of give yourself like, kind of like grind your teeth, kind of like make an issue out of it, pace in the room and do everything, and tell yourself, never ever do that error again. Even if it was just a negative, trust me, it will go a long way in trying to avoid those. There's another one, you say simplify. And students, it's just in a moment of pressure, as I say. They say simplify. You find a student struggling there to say, what do I do? Okay, they recognize that there are two brackets like this that are similar, so they'll take it as 2x minus 1. They say it's the first bracket. They take the second bracket, 2x minus 1, and then after that they see that there is x minus 3, and then they write that x minus 3. Or sometimes they start with that x minus 3, like x minus 3, and then after that they are like, I've got 2x minus 1 twice, which is 2x minus 1, and 2x minus 1. Guys, this is wrong. What are you supposed to do when you're factorizing here? Listen, whenever you are given already what's in brackets, 2x minus 1, 2x minus 1, you take 1, because this is 1 and this is not 2, this is still 1, so you're taking it as 2x minus 1. It's common between the two, and then what is outside the brackets, you've got that and that, which is x minus 3. This is complete, that's the end. You don't have to write this twice, you just have to write it once, because if you're saying 2x minus 1, 2x minus 1, you're saying it's appearing once. The only time you can write it is when you're given like this, x, 2x minus 1 minus 3, and then you've got 2x, maybe a plus 1. You see now the method changes, because this is different, this is 1, that one becomes 2, and the other outside they become 3. So that's when you can have 2x minus 1, and then you have 2x plus 1, and then you'll have x minus 3. Only then can you use this scenario. As I said, guys, this is not the only errors, but it's what is common that I always pick up when I'm working with my students. What most of the time students do, they just dismiss it as a small error and they're like, next time I'll remember, say. But that's not what I want. I want you to stop, to pause and make an issue out of it, from like you blame, make it a blame on you, make it an issue on you, and ensure that you tell yourself that you won't repeat that error again. No matter how minor it is, remember, it is costing you your maths. Your maths is supposed to have a good pass. Your maths is supposed to be at another level. But if you keep repeating these errors, you always find yourself tripping. You always find yourself getting low marks. And the only thing, if you can analyze that paper, you'll see that it was just a result of small errors. I hope you benefited from this. Remember, guys, to subscribe, to like the channel, share the channel with your friends and colleagues, and it will also become kind of a way of assisting those who are also struggling with this mathematics. Leave a comment. What are the errors that you find yourself picking up? I want to hear from you guys. Leave me some of the errors that are common. Send me some of the errors that are common, and we wish that if you had find a way of solving them, these will be actually take your maths to another level. I want to hear from you. Thank you.